All right, so today we're going to be looking at 2.4. This is over writing equations, finding our rational roots, and then dividing polynomials. So what I'd like for you to do first is this first page is really just a review of all the things that we've seen so far. There's a few things I want to go over with you, but we're going to start with number one. So we're going to write a quartic function that has zeros here, and 2 has a multiplicity of 2. Then it goes through this point. Well, using those zeros, I know the factored form of this polynomial is x plus 3, x minus 3, and x minus 2 with a multiplicity of 2 means that that factor is squared. So then I can use this point at 1, -4 to find that a value, that stretch or shrink, right? So I use that x and y value, plug that into my function. So -4 equals a times the quantity x plus 3, but I can replace those x's with 1's. So 1 plus 3, 1 minus 3, and 1 minus 2, that quantity squared. So 4 times -2 times 1 gives me a -8. So -8a equals -4. So a equals 1/2. That gives me a final function of f of x equals 1/2 x plus 3, x minus 3, and x minus 2 quantity squared. So that's what you're doing for a couple of these, but I want to look at number 3 real quick. So here we have a quadratic, which means it's an x squared function, and it has zeros of -2 plus I. So a couple things I need us to remember. Imaginaries come out in pairs. So that means if my function had a zero of -2 plus I, it came from a factor of x minus -2 plus I, right? Just like my factor of my zero at -3 gave me the opposite inside my parentheses. So really what happens with this is our real number flips signs. So rather than being -2, it's +2, right? Distribute your negative. Negative times a negative gives me a positive. And then my imaginary, I have a minus I. But because they come out in pairs, I also have a factor that's x minus -2 minus I, right? We plus or minus our imaginary portion. So that gives me a factor of x plus 2 plus I. The thing I need you to remember is we have to multiply these together. We can't have a final function that has imaginary numbers in it unless it wants us to keep it in linear factored form, which this one doesn't say, but I'm going to ask you to do that now. So if I take x plus 2 minus I and multiply it by x plus 2 plus I, I'm really just distributing each of these terms from my first set of parentheses to my second. So I would have x squared plus 2x plus ix. Then I'd distribute my 2. And whether you write these all in one line and then simplify, or you stagger them like I do, it does not matter. But what matters is what we get as the end result. So then I have plus 2x. When I distribute that 2, plus 2x, plus 4, and then plus 2I. And last but not least, I'm going to distribute that minus I. So I have minus xi, which makes sense because my ix and xi should cancel. Minus 2I, anything that's imaginary should go away. And then minus I squared. Well, I squared becomes -1. So my final result from this becomes x squared plus 4x. My ix cancels, my 2I cancels, plus 4 plus 1. So this came from the function f of x equals a, right? We still have that stretch or shrink, times the quantity x squared plus 4x plus 5. So those imaginary roots came from that quadratic. So now I need you to use that point of 0, 5 to find that A value, and then finish this first page. So go ahead and pause this video, and you can finish this first page with the people around you.